basic understanding is that x to the fourth and x to the fourth, that's a like term. Even if we're looking at x to the third and like a 2x to the third, that is a like term. Why is that? Well, think about it. If I put in a 2 for this here, a 2 to the third, that's 8. And then consequently, if I put a 2 in here, 2 to the third, it's also an 8. So we're applying a like term, a like number. So variables with similar exponents are like terms. And so when you're given and they like to represent it as like two separate pieces. You see how they're doing that? Like this polynomial, and we're going to add it to this polynomial. I believe this is let's call this a third. And first thing we're doing here, now this is just with one polynomial, right? Adding with one polynomial, we have our like terms. We want to evaluate it based on what's like here. And it's just simple, basically adding terms here, 2x to the third plus 4x to the third. Let's call it 6x to the third. Plus 3 plus 1x squared, let's call it 2x squared. Minus 5, minus 7, you're adding two negatives, so you have a total of negative 12. And that's when you're adding polynomials. Very similar to where you guys are subtracting. The only difference is you may have to rewrite or
so it's still
it's
still going in descending order.
Yeah, I think it's always good to list it with highest degree in descending order. Now let's say you combine your like terms and you present it in a way where it's not, they're not asking for highest degree in descending order. That's like this. This polynomial is equal to this polynomial. That's the same thing. They're equal, but this one is just listing in highest degree in descending order. So if that's what's being asked, I think generally you'll see this as a SAT multiple choice will be like this, but yeah, I think it also could be presented as this. So to understand both parts of that is important. Let's say you guys are subtracting. Yeah? Okay? Same idea with the like terms. Same idea with the like terms. What changes, and the common mistake students will make, is that they'll subtract the negative 5x6, they'll subtract that. But then when it comes to combining the negative 7 with the 9, they'll continue to subtract. And the idea is that you are essentially distributing this negative sign to each of these terms, and that you're subtracting it from each of these terms. So you can just look at, okay, negative 4x to the 6th minus 5x to the 6th would be negative x to the 6th. You can if you feel comfortable doing that. And that, plus 9 minus a minus 7 is really plus 7. Or you could take the time and just, if you feel more organized, negative, negative, positive, and then minus 9x to the 4th. If you feel more comfortable this way you already have the sign. You're not worried about the negative and negative. Okay? Then you have the 4x minus the 9x. 4x minus the 9x. And then you have the 9 plus the 7. This should have been 4. 16 there. Now again, I listed this in descending order, but if you had done the 4, then the 6, and then the 9, and that's how you listed it, that's the right answer. Like if you had, you talked about things being in the highest degree. So if you had listed it, like if you combined your x4 first, and then you basically listed as this was your final answer, you're correct, because you've correctly combined your like terms. Unless I say, please, provide your final answer in descending form. I think on your objectives, I don't think it's in descending form.
It's just there. You got it.
Yeah, some of it is, yeah, some of it's not. Now, Tamani, I just want to go over again. Yeah, add coefficients to it. Negative 2x squared y 3 plus 4 y3 x3 minus 6 y3 x2 plus 10 y3 x3.
Okay, what are we doing now, guys?
We're getting crazy, that's what we're doing.
No, I'm saying like that.
We're just looking at like terms
Oh,
and adding subtracting polynomials, so we're taking a look at like terms. Now what I'm going to look at, Simone, is I'm going to try to find, you know what, let's just add for fun.
Can we take baby steps?
Yeah, that's what we're doing.
That ain't no baby step.
no, baby son.
It may be a big
That's a
baby.
grown man step.
Maybe a big baby.
My brother is a big thing.
That's nice.
Let's just look at something like this. You with me? Just take, it's okay.
It's not recording?
It is. It's okay. We're in class. Let's try to identify some like terms. Sandy, good.
No, never mind.
Let's try to identify some like terms here. Hammers? Oh, you're gonna do it. Go ahead.
Oh, I'm gonna do it? Okay.
If you want. Well, what are we looking for?
It's like time.
Yeah, well, and how do we identify like terms? With the exponents.
Yeah.
So we have to find all the terms that match up with the x squared,
And
just the
y-
x squared and the
y cubed.
y cubed. So here I have an x squared, here I have an x squared,
Y cubed right there with the 6.
okay, and then here I have a y cubed, here I have a y cubed. This is a match. Even though the x and the y are in different order, remember xy is equal to yx. That's multiplication, okay? And 3 times 2 is the same as 2 times 3. So if these are in different order, that's okay. And I could say negative, and it doesn't matter how I list it. I could say it's negative x squared y third. Right? I basically changed the order of this, and now I've combined negative 2 minus 6, and I've gotten a negative 8. And we do have another match here with the y cubed x cubed, y cubed x cubed. Again, in this case the letters are in similar order, so nothing really to be concerned with there. And then here, no match with anything, so I would just list this. Probably need a little bit more space there. Negative 8x squared y third plus 14y third x3 plus 5x5 y3. Yes, this y to the third matches with the y variable and this term in this and in this, but the idea is that this is an x to the fifth And there is not a match here, and there's not a match here, so we're not gonna consider that like terms. Simone?